In this video, we're continuing talking about section 3.7, and we're going to see how to determine if there are any outliers in a data set. So this is the process. First, you calculate the IQR, which we talked about earlier. You need to calculate Q3, Q1, and subtract Q3 minus Q1. That gives you the IQR. Then what you need to calculate is Q1 minus 1.5 times the IQR. And Q3 plus 1.5 times the IQR. Q1 minus 1.5 times the IQR gives you what's called the lower fence. Anything less than this value is an outlier. Q3 plus 1.5 times the IQR gives you the upper fence. Anything greater than this value is an outlier. Notice it's not less than or equal to or greater than or equal to. So if I get something that's exactly equal to a value in the data set, then it is not an outlier. It has to be less than or greater than. So when we make a box plot, the whiskers go from Q1 and Q3 to the most extreme data values in the data set that are within the fences. So we don't draw the whisker to the fence, we draw it to a value in the data set that is not an outlier. And then we use a dot or an asterisk to mark the outliers. So we're going to do this example from our sibling data, and the question is, are there any outliers in this data set? So what we need to do first is go back to our 5-number summary. We calculated this stuff earlier, and we need to identify Q1, which we found earlier to be 1, and Q3, which we found earlier to be 3. And this was back in the video on measures of spread for section 3.4 and 3.5. So my IQR would be 3 minus 1, which equals 2. And I'm going to calculate Q1 minus 1.5 times the IQR. The value for Q1 is 1, and the IQR is 2. So we're doing 1 minus 1.5 times 2. You can type that into your calculator, or just do it by hand. That gives you a value of negative 2. So what this means is that anything less than negative 2 in my data set would be an outlier. Now that doesn't really make sense because it's not possible to have a negative number of siblings. So what that means is that there's not going to be any outliers on the left side or on the small side of the data. But let's see if there are any outliers on the big side. So Q3 plus 1.5 times IQR. Notice the difference in the signs. Q3 is 3 plus 1.5 times 2. 1.5 times 2 is 3, so 3 plus 3, which is 6. Now, I look at my data set and say, okay, are there any values in the data set that are greater than 6? There is one value that is exactly equal to 6. However, that's not an outlier. In order to be an outlier, it has to be greater than 6. So if there were a 6.1 in the data set, that would be an outlier. There's not a 6.1, there's nothing greater than 6, and so there are no outliers. So any outliers would have to be less than 2, or greater than 6. Sorry, less than negative 2 or greater than 6. So there are no outliers in this data. The last thing we're going to look at in this section is relating the box plot of a data set to the histogram. So if you have narrower boxes on a histogram, that indicates an area where the bars are very high or the frequency is high. Wider boxes and whiskers indicate a tail on that side. So comparing this histogram with this box and whisker plot, we see that we have the long whisker here on the right side, and in the histogram we have the tail on the right side. So this is skewed right. This one is symmetric. The boxes and whiskers are approximately the same size, and this one is skewed left. We have the tail on the left, and we have the long box and the long whisker on the left-hand side. So narrower boxes and narrower whiskers means higher bars are present there in the graph. Wider whiskers and wider boxes indicate that the bars are shorter in that area.